Hello everyone, welcome to VLSI Career Craft. Today we are going to see one more example on static timing analysis, hold violation and fixing hold violation concept. So let's get started. So in this question, it is given that a synchronous system which are having three registers and the setup, hold and clock to queue delays are given. And there are two combinational logics whose maximum and minimum delays are also given. So in the first part of the question, we were asked to calculate minimum clock period of the system, which is straight away. And then we were asked to check if there is any hold violation and how do we fix this. And the third part of the question is all about after fixing the hold violation, the minimum clock period of the modified system needs to be calculated. So if you observe in this question, the clock is coming to flip-flop 2 and then going to 1 and 3 with a delay of 4 nanosecond. So based on this, we need to calculate the clock skews for both the paths and then get into the question. So let's calculate the clock skews first. So for case 1, which is the path from flip-flop 1 to 2, the clock skew, T skew, is nothing but T capture minus T launch. Let's assume that the clock for flip-flop 2 is coming at time t1. So the clock to flip-flop 1 is coming at time t1 plus 4 nanosecond. Similarly, at flip-flop 3 also it is coming at t1 plus 4 nanosecond. So let's substitute these values in the clock skew equation. So T capture is flip-flop 2 in path 1. So T1 minus T1 plus 4 nanosecond. That is equal T1 minus T1, which gets cancelled. And finally, we are left with a negative clock skew of minus 4 nanosecond. This is for case 1. Similarly, for case 2, T skew is equal to T capture minus T launch. So here T capture is flip-flop 3. So the clock is coming at T1 plus 4 nanosecond minus the launch flop is coming at T1. So in this case, we are left with positive skew of 4 nanosecond. So with these clock skews, let's calculate the minimum clock period which is asked in first part of the question. So we have this equation. Again, we need to substitute the values according to this. The clock to queue is given as 4 nanosecond plus T combinational delay max in first case is 24 nanosecond plus T setup is given as 3 nanosecond, which is less than or equal to T clock, plus we have seen a negative clock skew of 4 nanosecond. So here it is nanosecond. Yeah. So that gives us T clock is greater than or equal to 28 nanosecond plus 4 nanosecond. So this is for case 1. Similarly, for case 2, oh, I'm sorry. In case 2, the maximum combinational delay is 30 nanosecond plus T setup is given as 3 nanosecond, which is less than or equal to T clock plus here in this case we observe positive clock skew. So finally we get T clock greater than or equal to 34 nanosecond minus 4, which is nothing but 30 nanosecond. So in these two cases, we see the worst case is path 1. Therefore, minimum T clock is equal to 32 nanosecond. Yeah, the first part of the question is solved. So let's get into second part of the question. Again, here it is nanosecond and nanosecond. Yeah, so we need to check if there is any hold violation. We have this equation and we have clock skews and delays. So let's substitute and see. T hold 3 nanosecond plus we have a negative clock skew less than T clock to Q is 1 nanosecond plus T combinational delay here is 4 nanosecond. That gives us minus 1 nanosecond less than 5 nanosecond. So in this case, we don't have any hold violation. So we are good here. In the second case, 3 nanosecond plus positive skew 4 nanosecond. It should be less than T clock to Q is 1 nanosecond plus delay. Minimum delay is 3 nanosecond. That is 7 nanosecond less than 4 nanosecond, which is not true, and we have hold violation here. So again, as explained in the previous example, we have two ways to fix the hold violation. Either we increase the combinational delay or we decrease the clock skew. So here there is no chance of decreasing clock skew. So let's add a delay in add a delay in the combinational logic B and solve the hold violation we are having. So let delta delay be added to combinational logic B. So what is the modified hold equation? The hold equation T hold 3 nanosecond plus positive skew 4 nanosecond less than T clock to Q is 1 nanosecond plus T combinational minimum is 3 nanosecond plus we have added a delay of delta. So delta should be greater than 7 nanosecond minus 4 nanosecond. So delta should be greater than 3 nanosecond. So minimum delay that needs to be added to the combinational logic path should be 3 nanosecond. So yeah, we have calculated what is the minimum delay which fixes hold violation. So now with this delay, we need to see how the minimum clock period of this modified system is changing. So that is the third part of the question. So we have delta equal to 3 nanosecond. So for calculating the clock period for path 1, we have clock to Q 1 nanosecond plus 24 plus T setup. 3 nanosecond should be less than or equal to T clock plus T skew. So T clock should be greater than or equal to 28 plus 432 nanosecond. So there is no change in path 1. Path 2, we have the added delay. So that gets added delay of 3 nanosecond plus skew setup of 3 nanoseconds again, and less than or equal to t clock plus positive skew of 4 nanosecond. That gives us 30, 34, 37, 37 nanosecond minus 4 nanosecond. So t clock should be greater than or equal to 33 nanosecond. So here we have worst case as 33 nanosecond. So minimum clock period of the modified system is nothing but 33 nanosecond. So yeah, so we have solved the third part of the question. I hope you understand the process step by step. Let's see more examples in future. Subscribe to the channel VLSI Careercraft, and you can follow us on Instagram as well. Yeah, thanks for watching.